Okay, let's look at the graph. So remember to draw the TS diagram for the temperature and the entropy change, right? So this is our TS diagram. So what do we know initially? The first step is an isothermal step. Temperature remains constant at 30 degrees Celsius. Okay, so you have 30 degrees Celsius. And then you have a horizontal straight line because the first step is isothermal. Alright? So you start with any point. Let's say this is your point 1. Where should it go? Should it be to the left or to the right? You look at your entropy change, right? Entropy change delta S1 is minus 3.43. So it's going towards negative side. Okay? So this will be your TS diagram for the first step. And this entropy change 2 minus 1 is negative. Therefore, it's going towards your right hand side. Okay? Then the second step is an isometric cooling process. We don't know what is T3, but you know it is a cooling process. Right? Cooling process means temperature should be lower. Right? It's an isometric process. The pressure reduced from 6 bar to 2 bar. So by your PV equation, P over T is a constant, so temperature should also be reduced. You don't have to find that new temperature, but you know that temperature is lower than 30 degrees Celsius, and that's sufficient. Okay? At some point lower. Somewhere lower, let's say this is the final temperature. Okay? Let's say you didn't find what is the final temperature, but you should know that T3 must be lower than 30 degrees Celsius. Okay? So from point 2, I must end up somewhere along this T3 line. And what is the entropy change for the second step? It's also negative, minus 6.8, right? So which means point 3 is again to the right hand side of point 2. Okay? So point 3 is somewhere here. And 2 to 3 is the isometric process. It is a curve under the TS diagram. So you join the two up with a curve. And that is your TS diagram. And what you label, you can label the overall delta S is your minus 10.2, right? Kilojoules per Kelvin. So both are negative. This part here is minus 3.4 and this part here is minus 6.8. You have to label the delta S. Not the S, but the delta S.
Oh, so kira kan yang dia circle aku yang setakat kena letak X gitu lah.
One day.
Aku fikiran.
So after the TS diagram, the last thing we need to do is to draw our PV diagram. Okay, so PV diagram is actually easier because you have all three pressure. You have the pressure at state 1, 2, and 3. All three pressure you have. So we start with the pressure first. Initially, my starting pressure is 1.5. Right, then I undergo an isothermal step, and that brings me to a pressure of 6 bar. So you know that your point 1 must lie along 1.5, your point 2 must lie along 6 bar. Alright? And then we need to look at the volume. Do we have the volume? You have an initial volume. Let's say initial volume is here. Okay, initial volume is 5 meter cube. Then after that, if it's an isothermal step and pressure increase, volume must decrease, right? Because PV is a constant for isothermal process. If pressure increase, volume must decrease. So you don't know what is the final volume, but you know that it's lower than 5. Okay, you don't know. It's okay not to find this V2, but you know that this number is lower than 5. Then isothermal process is a curve under the PV diagram, so you draw a curve. Okay? So that's for step 1. Then the second step is an isometric process. So constant volume. Volume don't change. When volume don't change, it must be a vertical straight line. Right? Does it go up or go down? We know because we know that the final pressure is 2 bar. So it has to go down to 2 bar. And because the final pressure is 2 bar. So you will go curve up and then go down.